Last week, we were working on calculating the gravitational effect on astronauts in the International Space Station. Let's review this information again. First, we must list our givens. We have a mass, the radius of the Earth, the height above the Earth of the space station, and of course the gravitational constant. So, the mass of the Earth equals 6.0 times 10 to the 24th kilograms. The radius is 6.4 times 10 to the 6th meters. The height is 3.5 times 10 to the 5th. And the gravitational constant is 6.67 times 10 to the negative 11. Now, the gravitational constant has newtons times meters squared over kilograms squared, but we're just going to ignore them for our purposes. The gravitation field of the International Space Station is, let me write, the gravitational field of A equals large gravitational constant times the mass, the radius of your object, plus the height from that object, both squared. So we begin with 6.67 times 10 to the negative 11, and we are multiplying that by the mass of the Earth, 6.0 times 10 to the 24th. They are our two variables that are on the top. As mentioned before, we must add our radius and our height before we square them. So our radius is 6.4 times 10 to the 6th, and we are adding that to 3.5 times 10 to the 5th. Again, before we square both of those. Let's break this up into a two-step process. We get on the top we get on the top 6.67, and we are multiplying it by the mass of the Earth. And this is our top, and our bottom is similar in nature. And again, we must add both our radius and our height before we square them both. Now, knowing that these exponents are very similar, we're going to have a number that is going to be very similar to this. Our answer we get is 8.78 meters per second squared. So choice is 8.8. Now we must remember this value for our next problem, 8.8 meters a second squared. We are asked to utilize that information to compare to the gravity on the Earth. So let's take a look at our question. It says, how does the gravitational field acting on the occupants of the space station compare to the gravitational field acting on you now? We have learned all year long that our gravitational force that we are experiencing is 9.8 meters a second squared. When you are looking for a comparison, you must identify what is being compared to what. Order matters. So you are looking at the gravitational field compared to the gravitational field on you now. So you are asked the gravitational field on the space station compared to you, and you're asked to evaluate those values. Well, knowing our inequalities, the space station has a slightly less gravitational pull than we are experiencing on Earth right now.